Hello everyone, I am Praveena Singh, TGT Maths from Kendriya Vidyalaya Bulandshahr, Shift 1. In this video, I am going to explain Chapter 3 Understanding Quadrilaters of Class 8. Let's check the points we will discuss in this chapter. We will discuss types of curves, types of polygons, classification of polygons, interior and exterior angles of a polygon, types of quadrilaters, some special types of parallelograms, properties of the parallelogram, and at the last we'll also study the properties of special types of parallelograms. Let's begin with the curve. We have different types of curves: simple curve, closed curve, open curve, simple and closed curve, and further simple and closed curve is divided into two parts: polygons and non-polygons. Now let's study each curve one by one with its definition. So what is a curve? Curve is actually a line or a shape which is smoothly drawn without lifting a pencil from the paper. Open curve that has no on end points. Here you can see first curve is having two end points. Second curve is again having two end points, and the third one is also having two endpoints. So all those curves which are having two endpoints are called open curve. Closed curve which has no endpoints, or you can find out the area which is enclosed in it. Here you will see this area is enclosed in it. So you can say yes, these curves are closed. You cannot find any of the end point or the beginning point. Third type is simple curve. So simple curves which do not cross itself. Suppose if your curve is like this. Now you can see here they are crossing each other at this point. So it is not a simple curve. So curve which does not cross. Here you will see here this curve is not crossing itself. So it is a simple curve. Another you can see, and also suppose if I am drawing this, again it's not crossing itself. If I am drawing something like this, again it's not crossing itself, so it is also a simple curve. Let's see the simple closed curve. As the name suggests, it's a combination of simple and closed curve. Simple means it should not cross each other, and closed means it should be closed, having no endpoints. Now I can see this heart is an example of simple closed curve. This arrow or a rectangle, or if I'll take a triangle, a circle, these all are the examples of simple closed curve. Let's move towards the next. Simple closed curve is actually further divided into two parts: polygons and non-polygons. So polygons means what? Simple closed curve made up of line segments means if our closed curve is made up of only lines, then it is called a it's called a polygon. We have few examples like triangle, this figure which is made up of only straight lines, hexagon, or a square, or a rectangle, or a rhombus. You can see many more examples, which all those figures which are made up of line segments only. Now what are the non-polygons? Which are not polygons means which are made up of curved lines. You can see here a little moon. It's made up of two curved lines. so it is a non-polygon. A circle, it's made up of the curved, so it is also a non-polygon. It's a combination of a curve and straight line, so again it is also a non-polygon. So non-polygons are all those simple closed curves which are made up of curved lines, only curved lines, or a combination of straight and curved lines. Now let's see the different types of polygons. Polygons are further categorized into the types regular polygon, irregular polygon, concave polygon, and convex polygon. Let's take a brief look on each of these types. Regular. Regular means all the sides and all the angles are equal. If sides and angles are equal, then it is known as regular polygon. And the best example is the square. I know that in square all the sides are equal and each angle measure 90 degree. So in this figure all the angles are equal, all sides are equal, so it is known as a regular polygon. Similarly, you will see a regular pentagon means all the sides are equal and also each angle is equal. Let's see the next type, that is irregular. As the name suggests, which are not regular. Means if, for example, a rectangle. I know that in rectangle all angles are equal, each angle measure 90 degree. But what about sides? Only the opposite sides are equal, but not all the sides are equal. So it is not regular. It is known as irregular. Similarly, rhombus. I know in rhombus all sides are equal. But what about angles? Angles are not equal. So again, it is not regular. For being irregular, all the angles and all the sides should be equal. If the figure is equiangular, sides are not equal, then it is not regular, means it's irregular. If sides are equal but angles are not equal, again it is not regular, means it is irregular. Let's see the third type. So third type is concave polygon. A polygon in which at least one interior angle is more than 180 degree. Also some portion of diagonal lies in the exterior. What does it mean? We know that in this figure, these are the interior angles. This is one of the interior angle, right? This is also one of the interior angle. Now you tell me, it will be a 90 degree. According to this figure, it will be a 90 degree. But what about this angle? This angle will be 270 degree. So what do you observe? We observe that this measurement of this angle is more than 180. Means the interior angle is more than 180. So it is a concave. Similarly, you can see here it is a 90 degree, but this angle is 270 degree. So again, interior angle is more than 180. So it is also a concave polygon. Now the second thing, if we join the non-adjacent corners, vertices, I'll get it outside. It is this, about this diagonal is actually lies in the exterior of the polygon. So it is a regular. We can find few of them which are in the, which lies completely in there, but not all. Few diagonals are in the exterior, so it is a concave. Similarly here, if you join these two non-adjacent vertices, you will find that this diagonal is also lies in the exterior of the figure. So again, it is a concave polygon. Let's see the fourth and the last type of the polygon, that is convex polygon. A polygon in which each interior angle, what is the measurement in this case? It is less than 180. And the diagonal lies completely in the interior. Draw any of the diagonal. You will find all the diagonals are in the interior. They are not in the exterior. Right? It makes a beautiful star. Okay, another, again, here diagonals are completely in the inside. Again, another figure, all the diagonals are in the interior. All the diagonals are in the interior of the polygon. So these are the convex polygon. And also we can see all the angles, interior angles, their measurement is whatever. I don't know the exact measurement, but I can say okay, yes, the measurement will be less than 180 degree. So two conditions are there. Number one, interior angle should be less than 180 degree, and the second, diagonal must lie completely in the interior of the polygon. Then that polygon is called convex polygon. Now we'll see the classification of the polygon, means the names of the polygon. We know that a single polygon is the minimum number of sides required to make a polygon is 3, and that 3-sided polygon is actually nothing but a triangle. 4-sided polygon is called quadrilateral. 5-sided is known as pentagon. 6-sided polygon is known as hexagon. 7-sided polygon is known as heptagon. 8-sided polygon octagon. 9-sided polygon nonagon. 10-sided polygon decagon. 12-sided polygon dodecagon, and n is called n. We know that actually polygon, the meaning poly means many, and gon is actually for the sides. So figure which is made up of many sides. So you can memorize in this way also. And their names, only the gon is added at the end. So for n-sided polygon, the name will be n-gon. Now, after let's see few questions to know our extent of understanding, how much we have actually understood. First question is, which of the following is not polygon? Now for this, not polygon means you have to recall the definition of polygon. What was the polygon? Polygon, many sides. Figure which is made up of many line segments. Triangle, yes, it is a polygon. Pentagon, yes, it is a polygon. What about circle? No, it is made up of curved lines. Let's see the next question. Which of the following is a regular polygon? Now what do we understood by regular polygon? Regular means all sides and all angles are equal. So in square, all sides and all angles are equal, yes. What about rhombus? No, sides are equal but not angles. Rectangle? No, all angles are equal but not the sides. So square is a regular polygon. Let's see one more question. Question number 3. Which shape is this? Star, but in options we don't have a star. Options are convex, concave or regular polygon. Now convex polygons means was each angle measure less than 180 and also the diagonal in the interior. Now if I join the two vertices of this star, I'll see this line is actually in the exterior. So obviously it is not convex. Again, is it a concave? Yes. Regular, for being a regular, all angles should be equal, but I can see this angle will be less than 90 degree, and this angle will be definitely more than 180 degree. So obviously again it is not regular, although it looks that all the sides measure equal, but as angles are not equal, it is not a regular. Okay, so I hope with this we have understood the polygons. Now we'll see the next topic, interior and exterior of the polygon. So let's first of all understand what do we mean by interior and exterior. So here I have drawn a five-sided polygon. So five-sided polygon is known as pentagon. So here I have drawn a pentagon. Now in this, if I extend, so this interior inside the portion is called the interior, and these are the interior angles: angle A, angle B, angle C, angle D, and angle E. And if I extend each side, I'll get the exterior angles here. Okay, so what are the exterior angles here? One is the exterior angle which is adjacent to A, 2 is the exterior angle, 3 is the exterior angle, 4 and 5. These are the 5. How we get the exterior angle? If we extend the line segment, we will get the exterior angles. Now what is the relation between the interior and exterior angle? Let's see one of the relation. You can see if we extend this side, so actually it's a straight line, and we can observe on this straight line angle 1 and angle A are there. So they are actually forming linear pair. So what do we mean by linear pair? Means the sum of these two angles is equal to 180 degree. So sum of the interior and its corresponding exterior angle is 180 degree. Very important last point. Okay, after understanding the interior and exterior, now let's see a few more properties about the interior and exterior angle. So first of all, we'll see the sum of interior angles. So actually we have a formula. The sum of all the interior angles of a polygon is n minus 2 into 180 degree. Let's see how it works. So first of all, we'll consider the smallest polygon, that is three-sided polygon triangle. And I know that the sum of all the angles of a triangle is how much? 180 degree. Let's put the value here. In place of n, I'll write the number of sides, that is 3. And 3 minus 2 into 180. So 3 minus 2 is 1. 1 into 180 is 180. So I'll get 180. Okay, now let's check the same formula for the next polygon, that is four-sided polygon, name is quadrilateral. Quadrilateral, we know that how many sides are there? 1, 2, 3 and 4 sides. And we also know that the sum of all the angles of the quadrilateral is 360 degree, because it's a combination of two triangles. Okay, so let's check the formula, the same formula for the quadrilateral. So again, n is the number of sides, so I'll put 4 here, and 4 minus 2 into 180. So I'll get 4 minus 2 is 2, 2 into 180 is 360. So similarly, for the six-sided polygon hexagon, number of sides is 6. Minus 2 into 180, I'll get the sum of the interior angles is 720. So I hope you all have understood. Now directly for the smaller triangles, I know the formula, but now with this formula, we can calculate the sum of all the interior angles of n-sided polygons. Means if you have given what will be the sum of all the interior angles of a pentagon, decagon, nonagon, easily you can calculate with this formula. Okay, it's all about the sum of the interior angles. Now let's see the exterior angles. So for this also we have a formula, but it has a one interesting formula. What is interesting in it? The sum of all the measures of exterior angles of a polygon, one at each vertex, is 360 degree. So what does it mean? It means if I have a polygon and suppose it's a triangle and extend each side, I'll get the exterior angles. So first exterior angle A, second B, and third is C. The sum of these three angles A plus B plus C is equal to 360 degree. So it is valid not only in case of triangle but in all the polygons. The sum of exterior angle is always 360. And with this we can also we get two more formulas. The formula of one exterior angle, if you want to calculate one exterior angle, so formula will be 360 divided by the number of sides, and another formula is exterior angle is equal to 180 minus interior angle. So we have few formulas to get the number of sides if exterior angle is given, and we know the relation between the exterior and interior. They forms a linear pair, means to get the one angle, exterior angle, you can subtract it from the 180 degree. Here same examples are given. Exterior angles, their sum is always 180. Another is an example of a pentagon. Again the sum of all the angles is again 360 degree. So with this actually we have completed the curves, their types, and the polygons. But our chapter is understanding the quadrilaters. So now we will start our topic, that is quadrilateral. So quadrilateral is actually what? Quadrilateral is a simple closed curve or a polygon which is made up of 4 line segments. Okay, let's see. Now let's understand the values actually. First of all, let's solve few questions. The measure of each exterior angle of a regular polygon is 15 sides. Okay, so what do you have to calculate? You have to calculate the exterior angle. What is given? You have given number of sides, and that is 50. So how you will calculate this? The sum is 360 degree and number of sides is 15. Divide these two values. You will get, cancel it by 24. So what is the measure of each angle? It's 24. Option B is the correct answer. Let's see the next. How many sides? Now in this case you have to calculate the number of sides of a regular polygon if the measure of exterior angle is 40. Now measure is exterior angle is 40. We know that sum of all the exterior angle is 360. Measure of one exterior angle is 40 degree. Divide them, you will get 9. So what will be the number of sides? 9. Now we'll see the quadrilaters. As the name suggests, quad means 4 and lateral means sides. So any polygon which is made up of 4 sides is known as quadrilateral. Let's see the different types of the quadrilaters here. Quadrilateral is basically divided into the 3 parts: parallelogram, trapezium, and kite. Parallelogram is further divided into the types rectangle, rhombus, and square. Now let's see each and every quadrilateral one by one. So our 3 basic types are actually parallelogram. So as the name suggests, a word parallel is here. So means a quadrilateral in which both pairs, we know that how many pairs we are having? 2 pairs. So both pairs of opposite sides are parallel, is known as parallelogram. Second is trapezium, in which only one pair of opposite side is parallel, is known as trapezium. We can observe here that these two sides are parallel and these are non-parallel sides. Now the third type is kite. Kite in which pair of adjacent sides are equal, means the above two adjacent sides are equal and the below two adjacent sides are equal and opposite sides are not parallel. Now we'll see some special types of parallelogram. Special types of parallelograms are rectangle. So rectangle, what is rectangle? Rectangle is a parallelogram, means its opposite sides are parallel. But what is the speciality? Its speciality is all the angles are equal, means each angle is 90 degree. Next we'll see the rhombus. Again, rhombus is a parallelogram, means opposite sides are parallel. But what is its speciality? All sides are equal. Let's see the third type of parallelogram, that is a square. Square is a parallelogram in which all sides and each angle measure 90 degree, means all sides are equal and all angles are equal. Or we can say that square is actually a combination of rectangle and rhombus. After this, let's see properties of the parallelogram. So parallelogram, let me draw a parallelogram here. Opposite sides are parallel. So here opposite sides are parallel. Opposite sides are equal also. Suppose if it is 6 centimeter, it will be 6 centimeter. Opposite angles are equal. These are opposite angles. If I name it as A, B, C and D. So A and C are the opposite angles and B and D are the opposite angles. They are equal. Suppose if it is 60 degree, so it will be 60 degree. Fourth property is diagonals bisect each other. We know that in quadrilateral we have two diagonals and these diagonals bisect each other at the point of intersection. Means it's bisect means it's dividing into two equal parts at the point of intersection. After this, let's see the properties of rectangle. As we know that rectangle is a special type of parallelogram, so it satisfies all the properties of parallelogram. Means in rectangle also opposite sides are equal, opposite sides are parallel, and opposite angles are equal and diagonals bisect each other. But as it is a special type of parallelogram, so its speciality is each angle is 90 degree. Another is diagonals are equal. Suppose if it's given the length of the one of the diagonal is 12 centimeter, then the length of another diagonal will be 12 centimeter. So it is its speciality. Let's see the another type of parallelogram, that is rhombus. So again it is a parallelogram, so it satisfies all the properties of parallelogram, means opposite sides are equal, opposite sides are parallel, opposite angles are equal, diagonals bisect each other. But what is the other speciality? All sides are equal. In rhombus all sides are equal, and second is diagonals are perpendicular to each other. Diagonals which are bisect each other, they are also making a 90 degree angle at the point of intersection. Now let's see the last properties of a square. So all the properties of the parallelogram, as I told you, square is a combination, it is a special type of parallelogram. Okay, and it is a combination of rectangle and rhombus. So obviously it satisfies all the properties of a parallelogram, rhombus, and rectangle. So with this, our quadrilateral chapter is over, in which we have studied about the first of all different types of curves. Then we have studied the different types of polygons. Then we see the special type of polygon, that is a quadrilateral. Then different types of quadrilateral. In this class, 8th class, we will study only about the quadrilateral. So we have studied about the parallelogram only, in which we have studied about the different types of parallelogram and their properties. I hope you all have understood very well. So with this, thank you.